Hi, my name is Ben and I'm a rising sophomore at Regis High School. My first milestone was to connect the servos and motors to the Arduino and get them working with the input from the flex sensors. The flex sensors are variable resistors, meaning that you can adjust the amount of resistance they introduce into a circuit based on the extent to which you bend them and flex them. And before I set up any of the two circuits you see here, I just created I used sample code that I found online, just created a really basic circuit with only the flex sensors to test how they would work and react. What I found is that when they're straight or at 180 degrees, they'll produce approximately 10 kiloohms of resistance, and when they're bent about 90 degrees, they'll produce around 20 kiloohms of resistance. And also on both of these circuits, there's a voltage divider between the resistors in series and the variable resistor of the flex sensor. And the purpose of this is to create a voltage output that's a fraction of the input so that the Arduino can handle it. So this is my setup for the circuit with these servos, and the way it works is that when you bend the flex sensor, the servo will move proportionally to how you bend it, and the servo is actively responding, so the second you let go, it'll return to its original position. So here's the Arduino connected to the DC motor, and as you can see, there are two flex sensors on this. And the reason I did that is because I began experimenting with brief, just small combinations with the two, since that's something I'll have to develop as I continue my project. And also on the breadboard, you can see an H-bridge, which functions to allow the motor to spin either forwards or backwards. It allows the current to be applied across the load in both directions. And the original schematic I found for the motors was controlled by a switch, which has digital connections. And obviously I'm using flex sensors, so I had to adjust the schematic since flex sensors have two pins and it's analog. And the main difference between digital and analog is that digital is read on the pins as either high and low, on or off, 1 or 0, like binary essentially. And analog is more dynamic, which is what the flex sensors have, and it's read as a value, a number, or an integer between 0 and 1023. So I had to adjust the connections with the jumper cables, jumper wires, and that solved my issue, and now I see I have it working. When you push one flex sensor, the motor will rotate one way, and the combination is that when they're both pressed or both flexed, it'll change directions and rotate the other way. And as you can see, that works. One challenge I faced came with the Arduino receiving values from the flex sensor with the servo. It only received, it didn't receive the full range of values from 0 to 123 from analog readings. It only received values from 130 to 350. So to adjust this, I changed the mapping function in the code from the input range of 0 to 123, change that to 130 to 350, and map that to a value between 0 and 180, which is how the servo would rotate and move in 180 degrees. And because originally, when it was the input was from 0 to 123, 1023 rather, I only got a few degrees range of movement from the servo, and when I changed the mapping function, it could move the full 180 degrees.